Started in Silicon Valley in 2010. There are hundreds of chapters in all the places people live. There are no Antarctica chapters, no chapters on the moon, but every major venture market in the world. And we're just here to help people make connections and navigate into the venture ecosystem. So in particular, the Princeton chapter focuses on first-time founders, the resources that are available to them, getting ready to talk to institutional money, and have confidence that you'll be prepared appropriately for that conversation. And just, we're here to, so we talk about making friends, not contacts, and I hope you all make some friends when you come here and really engage with the other people here as human beings. I've made many good friends over the decade I've been doing this. Thanks. So I'm going to talk specifically about a couple of StartupGrind things and then hand it over to my colleagues who are going to do more technically crunchy stuff. But first, what events are on the docket? Second, we are doing a collaboration to help nonprofits connect with technical people that want to improve their Gen AI skills. And we're in the middle of the first cohort. We're looking to populate the second cohort. And then the third thing is one of the other hats that I wear within the local startup community is there's a National Science Foundation program called I-Corps. I-Corps gives grants. So grants are free money. You have to do the paperwork for the federal government, but that's it, to early stage companies to help them commercialize their ideas. And I will be running a regional cohort here in Mercer County in the third quarter. And if anyone is interested, I'm a teacher, I'm a member of the program. I think it's great, but that doesn't mean you have to think it's great. But if you're interested in getting coaching and resources and introductions, particularly around how to do customer discovery, how to get out in market and get reactions to whatever shiny idea you have, because you would not be the first founder that thought their stuff was amazing and went out to the market and found that nobody was really interested. So with that, I'll dig into upcoming events. This week on Thursday, we'll have a workshop that is one of the formats we run, and it's specifically around how to create a sales process for an early stage company. So not how to do a sales call, but how do you structure a sales team? How do you think about the feedback loop? How do you manage that process? And Glenn Carvello will be conducting the workshop. He has deep experience in setting up sales organizations with early stage companies. We'll probably do a meetup in July. I will tell you that the Venn diagram for the three of us for July just totally failed. So we might not do a July meeting around. This is very, very early in the build-out process, but there is a venture firm in the building here that has done over the years fairly large venture investor-facing events in Boston and Miami and the Bay Area. And now that they're based in Princeton, they want to do one here in August. And I don't know how big that's going to be, but it's going to be in August. So I think there will at least be a pitch event for AI startups, a pitch event for probably biotech, maybe a little broader in the life science area. And it may be quite a bit bigger than that, but we're still figuring out team and budget and lots of things. So and working with a team advised by the three of us at some level on making a smart chatbot, and sort of the goal here is to have a repeatable process where there's a well-defined pathway for techies to get the skills and connect into the AI builder community on the one side, and on the other side to do some good for the many nonprofits that exist in the state. So I think that we will report out on the first cohort, but I would like to have already recruited the second cohort before the first cohort finishes, so that we're not having this gap where we're trying to assemble the next team. So if any of you as technologists are interested in participating in a project like this, I think Mehul's got some forms, is that? But reach out to us.
Sure.
If any of you are working with a nonprofit, that the more complicated and confusing the stuff that you do is, the better. But you need to be willing to put in 10 hours a week with the tech team. So it's not write a memo and tell them to come back in 8 weeks. And then the last thing is I-Corps. So I-Corps is a program that's been around since 2010. Almost 4,000 teams have gone through at a national level, and probably 40,000 at a regional level. I don't know those numbers, but we did 300 last year in the Northeast hub. And this is a way to get exposure to people who've been teaching startups for a long time, to learn about how to sharpen your story around value proposition and how to identify your market entry segment. And I will tell you that if you don't do those two things, the rest of your model is almost meaningless, because the answer is it depends on those two inputs in a very material way. So you'll have a chance to apply to this particular cohort that I'll be running in the third quarter. Is a little unusual in that most of the cohorts are tied fairly tightly to deep tech research happening on campus at a particular university. And this is by design for teams that are not coming from, it's not grad students who already have something that they're working on for their doctorate or their postdoc. But if you have an interesting startup idea, you're eligible for this program. And if you have, basically the deeper the tech is, the better fit you'll be. And we'll take probably 8 teams and work out a schedule based on the availability of all of that. So with that, I'll turn it over to Mo.
Some big names on here say intelligence is the ability to accomplish complex tasks, right? Or the ability to see patterns. So given that, next. Early intelligence back in the 60s and 70s and 80s, when computers started becoming more and more common and ubiquitous. What happened was, for instance, let's say you drive up to a traffic light, right? And you go over sensors. And the sensor records, how much traffic is coming in and out. And it makes decisions based on if-then logic, right? If there's so much traffic, if the sensor has clicked like 100 times, do this, for instance, right? So that was where traditionally, early intelligence, it was intelligence, but it was very rudimentary, and it could be something that was programmed by people or experts in the domains. Moving on from that, we went into machine learning. So the way machine learning, for the folks in here who are not technology experts, what machine learning is, so for instance, let me give you an example. So if a human had to define, how would you say that this is a cat or this is a dog? There is very little a human being can program to always say that, if they're whiskers, then likely it's a cat. It's not a fail-proof method, right? You can be writing hundreds or millions of lines of code to be able to categorize a simple image. So the way machine learning works is you feed it a lot of pictures of cats and dogs. And at the end of the day, the machine learning model learns by itself. Learning where the machine learning models were designed and architected to work like the human brain. So think, for instance, the light falls on the retina on the back of your eyes. It goes back and it goes through pathways of different neurons, and there's a processing that happens in the back, right? So deep learning models were the next step from machine learning. And then it could do things like image recognition, speech recognition, language translation, all those things, they became very possible. That were, up until then, were very difficult. So that was like early, starting from the mid 1990s. Up until now, it has been a very well proven model. And it has, so for instance, if you're driving a self-driving car, right, it recognizes there's a stop sign coming up. So all those things are typically deep learning models. The new kid on the frontier is generative AI. So up until then, what happened was the models, or the machine learning models up until that point, they were able to do a certain task, but they were not able to generate content. And generative AI comes on the block, and now it can start generating content, right? So it can do like blog articles, or it can create like videos, for instance, or it can compose music for you, and for developers like me, it can actually even generate code. So it's not there in terms of accuracy and stuff yet, but it's getting there. ChatGPT or Google Gemini. But ChatGPT is a lot more, Gen AI is a lot more than just chatbots. So then what I personally work on a lot is agents. So agents is what happens is the generative AI can take action. And I will give you a for instance, right? That suppose you go to a website and you want to say that I want to design, let's say, sneakers for myself, or a shirt for myself. It can look at your history and it can generate content, right? So now it starts becoming more powerful. So it is like a product design expert. Or now what is really picking up steam is combining different agents to perform complex tasks. So there might be an agent that is good at giving, let's say, sifting through a contract. There might be an agent that is good at, for instance, sifting through medical documents. And now the two of them can talk to each other, right? And now you see it becomes more powerful. So you have a swarm, or you have many different specialists who you can think of that work together to create a swarm of agents, right? So the final frontier, I think, is we are not too far from a place where we are going to automate every single thing. AI will going to do farming for us, it's going to do legal work for us, it's going to do the physician's work for us. It's still maybe 10, 15, 20 years away. But that's called generalized artificial intelligence. So I wanted to lay this foundation because
can now do things with. Before, an image made sense to people, but if you wanted to search against it, someone had to very often manually look at the image, get all the information, and hand code that, put that in a database, and someone wrote an application to search. Now, unstructured data can be used programmatically and automatically with lots of Gen AI and AI use cases. And just who can do, I could take a picture of something and use that as my search. I don't even have to say anything, don't have to type anything. Take a picture of a dog and search with that. I could talk and have it search based on that. I could take a big document, put that somewhere and say, give me the 50 closest documents to this. And of course, we have to store all this data to do that. What makes that a little difficult, though, is before some of the technology that Hul was talking about, to take an image and make that available to quickly search just wasn't doable. With the current vector technology, you take a model, I take a deep learning model or an AI model and have that convert that into a very large string of numbers. And that happens really fast, especially if you have good hardware, which is why NVIDIA's stock is just did that 10-way split, and maybe I'm retiring tomorrow. It's just, they need that horsepower to be able to do this really complex math fast. Fortunately, with the vector databases, there's a way to have that done with those models, quickly put that in there for storage, and then very easily be able to use that to search. What's nice about that is if I'm doing, like you said, if I want to search against an image, I take the image, apply a model to it, and then it becomes that string of vectors. And then when it goes against our vector database, it uses a number of different mathematical algorithms to see if it's close to something else. And what's nice is there's lots of different ways things can be similar to each other. And that's what makes this a little different from a regular database, which did exact searches. You know, maybe I want to see other fruit, you know, other things like that. And then the thing you see with that is that becomes huge though. So being able to do that for lots of different things is pretty interesting. Now the use case most people have been starting with is, we were talking ChatGPT. Writing, you think you just write a question there and it gets you back a good answer. If you've tried ChatGPT and you just put in a question, sometimes the answers are ridiculous because it doesn't know. It doesn't know what it doesn't know. It's like asking a person who's a liar, you know, the answer to something and they're never going to tell you they don't know. They'll be like, oh yeah, sure, that's what's 1 + 1? It's dog, and you'll be very confident about it. So the way to get around that, people started coming up with this pattern to augment what you were going to ask for that model with information you actually know. Now that again was hard before because the stuff you know could be a big PDF, could be email, could be an image, could be a video, and you need to search that sub-second. Because if I spend 5 minutes finding the results and then spend another couple minutes cleaning it up and then hand it over to your chat, you've already left because you don't care. People are not willing to wait for data anymore. Results I'll give you back the closest 10 or 20 things that are based on what you asked, regardless of what it is. Like if I put an image in and I say, I take a picture of this room and go, give me the results. And if it knows, if it could see the building, maybe I could put some other stuff in there. It may have a similar picture from previous meetups. So if I have a database of photos from the meetups, which I do, it searches and says, oh, this is a meetup. This is the meetup in Princeton. So I will give that result back and make the prompt go, hey, ChatGPT, look at this information I'm giving you only. With this as well as we can add a lot of other metadata around it besides these vectors, which are just really big numbers. And for some of these, it may be, how do I reassemble those vectors into something that makes sense for people to look at it? Because if I took every document in the world and chunked them up into little pieces that can search back quickly, I need some metadata. So we have metadata in there too. And the way this has been happening for the last 3 or 4 years for some really large companies around the world is using open source database for this. So what this means is there's teams around the world working to make this the best way to do this. And it's been, expanding pretty frequently because it's not just chatbots which need to be able to search things that are maybe weird. But this one's been coming up a lot. We've got a couple of pharmaceuticals who are discovering new drugs because they could search by molecules. So someone could come up with a molecule, draw it in a system and go, okay, I think it looks like this, and match things that look like that. And go, hey, how about this? And there's a lot of things. There's a couple of people who are using this plus some Gen AI to come up with new drugs. And that's just going to get more powerful as people go, oh, what if I can analyze someone with video and start doing quick searches and add other sources of data? Now I can search images, 3D images, specialized images for molecules, all different kind of things from one system. Recommendation systems have been really big. Because when you're doing recommendations, say you have a store that has 1 million items. So to be able to look at the logs of what people have done, images from it, catalogs, and be able to connect things that are similar. So if I want a red shirt, I send you a picture of a red shirt, but if it's, I'm not just going to give you any generic red shirt, you know, it's going to match the style as close as possible. And maybe there's other elements in there that I can match up against as well. Maybe there's some text, people describing it, or you want to describe them all stored in the same place. And the thing we found out working with some researchers from around the world, working with NVIDIA, is there's lots of different ways to do this. A big supporter of this has been Facebook Meta. They've come out with a really good search system, and some people just use that. But we found that that only works for certain use cases that fit their needs. Like something like NVIDIA's GPU indexing is really fast. Since some people need the results back really fast, even if I have a billion things in there. So we let people do a lot of different ways of indexing their data to make it available. So you could search different ways, whether it's audio, video, however you want to search. And how do you want to get back data? Most common is people want to see the top 20 results, because either the nearest results. We're not giving you an exact match. There are ways to do exact match, but if you do that, it could be really slow. And how do you do an exact match when you're having concepts, you know? Find me something that's the color of a sunny day, and you're like, well, how do I get the exact match of that? I'm going to skip over these, how we actually wrote it, because that's really weird. Well, let's see, we'll show you. Maybe we'll sneak ahead. Maybe I'll show you a couple math. Anyone want to see math? Talks in San Francisco, and there's 100 people come for them because they want to implement their own. But yeah, just some of the things that you have to worry about with this is cost. I mean, that's a big one. We've had problems where people want to put everything they own in the database, and you're like, well, have you figured out how much it's going to cost to store and everything? So really optimizing things to save you money is kind of an important thing we do in the open source. If you write it from scratch, like some people think they should write their own vector store and it themselves, or try to put it in another database and then try to figure out how to manually put it together. Just kind of silly there. Yeah, I don't want to go too deep, but if you're interested, I've got a couple of articles that describe some interesting use cases. I've got one where I'm looking at the street cameras in New York, and then I'm storing them in a vector database. So if you want to search where you are right now, you take a picture and you send it against the database, and it says, hey, you're near 12th and 11th, and there was an accident there 2 days ago. And then you could start mapping that to other data, because you could have a graph of other data you're looking at, like what companies are over there, look at crime statistics, anything you want to do. Pretty interesting stuff. Is there any questions, people?
Your Town Tube is today's #1 all-local promotion, social media, and networking in the central New Jersey region. The most attractive, fastest, and most affordable ways to reach a huge local audience.